Welcome to breadboarding. In the previous video, we looked at our 386 breadboard PC design. In particular, we looked at the COMPAQ DeskPro 386, which is the PC that we're going to be basing this design on. But one of the big roadblocks really to start with this is how do we plug our 386 into a breadboard? Now, in the previous two series, the first breadboard PC and version 2 breadboard PC, we used the Intel 8088, which comes in a 40-pin DIP package, which is fairly easy to plug into breadboards. But the 386 had significantly more pins. In fact, we've got 132 here, and this is in a 14 by 14 grid. And the challenge I'm trying to address in this video is how can we make a breadboard adapter for this size of chip? So this is video number 3 in the 386 breadboard PC, and in this video we're going to be building a 132-pin 386 breadboard adapter. So in the previous videos there'll be links for the previous video at the top here, and there'll also be links to the whole playlist in the description below. You can go through the whole series if you've missed any videos. We covered the detailed schematics that we're going to be working from for this particular project, in particular the publicly available technical reference and some internal COMPAQ design documents that also include some of the program or logic device logic definitions. So the 386DX is 132-pin PGA socket, so I think that stands for pin grid array. So we need this breadboard adapter. Now, a number of people had pointed out in the comments, so thanks very much for all of those of you who comment. Do try and get back to you within about 24 hours where I'm able to. A number of people had identified this Foxtech 486 project, which I had looked at previously. There's about 7 or 8 videos here where he goes through basically building a PCB breadboard adapter for a 486. And this is sort of during the first video where you can see this is all plugged in. I did consider making a PCB for doing this, but really I'm not that knowledgeable about making PCBs, and the whole purpose of the Breadboarding Labs channel was really to try and make everything as much as possible with either solderless breadboards or solderable breadboards. So that'll be protoboard, stripboard, veroboard, that type of thing. So I'm going to try and make one using some protoboard and a number of sockets. But first of all, let's have a look at the Intel 386 datasheet. We'll be coming back to this datasheet quite a lot during the series as we have to cover various aspects of the design. But the first thing we really need to look at is the pin layouts. So we have the pin layouts from the top side. This is looking down on the chip. And we also have it from the pin side. Now, the key thing we need to be aware of is that the dot on the chip and the sort of the diagonal corner part of the chip tends to be on the A1 side of the chip. But obviously, when we're looking at it from the underside, it's on the opposite side here. And we can see here that we've got 1 to 14, and we've also got A to P. Now, in fact, you'll note that we don't have I and we don't have O here, because those could be quite easily confused. Further down in the document, there's also some mechanical information about the size of the chip and the diameter of the pins that we'll come to in a few minutes. So just take a look at these pin layouts in a little more detail. So what I've done here is I've superimposed the 386 chip on here, and you'll notice that where the dot for pin 1 is here, when it's in the correct orientation here, then in fact the logo is upside down, which I think could cause some confusion, so we need to be aware of. And this is also the orientation when we're looking from the pin side, and you'll see there this is where the diagonal is, and there's a little dot there as well where pin 1 is, and you can see over there as well. Now, in thinking about this, it's 14 across and 14 down, but I think it's easiest to think about this as a block of 3 rows of 14, another 3 rows of 14, and then 3 columns of 8, another 3 columns of 8. And when you work that all out, I think we've got 42, 42, it makes 84, then 24 and 24, that's 48, and overall that gives us our 132 pins. Now again, in the datasheet below it, there is then this sort of pin out chart here. And the key thing to note really is that when we're looking at all of these, we're dealing really with the letter and the number for the position. And obviously making sure I don't make mistakes in wiring this up is going to be quite tricky. I also notice over here we have a certain number of pins which aren't connected, so these are not connected. And there's quite a few power pins, and in particular we need to make sure that the ground pins are connected fairly regularly because of the number of I/O pins that the chip has got. So just have a look at the chip here. So this is the 386. You need to be careful with it because it is a CMOS, so you can damage it with static. So you can see that is our chip. Now, I haven't managed to measure the pins on there with a gauge here, and they seem to tie up with the information in the datasheet. This is a PCB PGA 132 socket, which I did get off eBay. Unfortunately, the pins on here are only about 3mm long, so they hardly stick out at all on the other side of the PCB. And really, unless we were making a dedicated PCB for it, then really that socket isn't going to work. Now, I've got quite a few different size header strips and things. And what I was looking at is, based on the dimensions of the pins and things, I was searching for the appropriate way to make a connector. I've got lots of these sort of various strips here. These are 19mm long header strips, which are quite useful because they're quite a bit longer than normal ones. There's kind of medium-sized ones here, 15mm, and I think these are the standard ones, which are about 12mm, half an inch. And there's also these stackable header strips I've used in the past, but I don't think we actually need to use those. And this set of strips is quite interesting. We'll see when we come to the sockets that there is a slightly larger diameter pin on one side there, and this smaller pin here is actually very close to the dimensions of the pins on the chip there. So I'm just going to show you some of the sockets that I was investigating and looking at, and we'll look at the dimensions of the chip itself. So this is some of the information that's in the datasheet, and I'll just go through some of the key dimensions here. So you can see that the distance really from the base of the chip here to the end of the pin is given in this purple dimension, so about 4.1mm. Then we've got the thickness of the bit surrounding the joint of the pin into the chip package itself, which again is about 1.2mm. So that gives us the length of the pin really there is just under 3mm. You can see that the diameter is sort of 18 thousandths of an inch, 0.47 of a millimetre. And I was able to find a place, Switch Electronics did these single inline sockets, and the key thing about these things is that the hole diameter is from 0.4 to 0.56 millimeters. So if we look at the diameter here, then these sockets should actually fit quite nicely, and they've got really quite nice long tails on them as well. Unfortunately, they're circular rather than square, and so if I want to use wire wrap, then I may have a few problems with this, but I'm going to be talking about wire wrapping in a second. But I'm hoping that I can, with enough turns on here, and perhaps I might have to top off a few of these with solder if I have any problems with them, but it seems to be a better way of doing things than the alternatives I was looking at. Just have a look at the data sheet for those pins. This is a socket strip from Switch Electronics in the UK, and the key thing is that the dimensions that I've already shown you there, and the fact that they're deep enough to actually accept the chip, and they've got nice long tails. They're not strictly speaking for wire wrap, but they are long enough for wire wrapping. Ideally, they would have a square cross section if they're wire wrap. And the inside of the socket is also gold plated phosphor bronze, so hopefully that should give us a good contact for our CPU. So this is a pack of the socket strip, and you can see here they've got quite nice long tails, and we should be able to make our socket out of that. Now, I was looking at how to mount this on the breadboard. I tried all sorts of various combinations. I was using the PCB socket for trying this out. One of the things I'm trying to do is to make sure that where the pin outputs here, particularly for the data bus and the address bus, that if I arrange the pin spacing appropriately, it should actually be able to plug straight into the breadboard and actually sit with one side of the latches and buffers that we need, so that rather than having to have extra wiring going off of the adapter here into the breadboard, they'll actually be plugging straight in the breadboard, and then the buffers and things will then be able to go off to the rest of the circuit. So I'm trying to do this, and in the end I decided not to chop down this proto board. You can see this proto board, that the holes here are just through plated and allow you to solder between the top and the bottom, but there aren't actually any connections between any of these pins here. So if I just show you now the layout that I've settled on. So what I have done is, in messing around with all the layouts, I've ended up sacrificing one of my breadboards here, and I need to have the space in here to allow the tails of the sockets to actually have enough space. So what I did is I chopped up one of my breadboards, and it's quite handy in that it actually can be used to actually fix these quite nicely and securely together. And then this is the socket that I've made. This is made up of these sockets here. What I have done is use some of those circular pins to actually tie various bits together. So what we've got here is a row of 3 rows of 14, 3 rows of 14 down the bottom, and then 3 rows of 8 along the sides there. And these pins here are just used to secure the various rows together. And you can see on the back there, this is then where we will do our wire wrapping onto these. So I'm going to cover what wire wrapping is all about in a minute. And then all we need to then do is to find something to plug this into here. And in fact, what I end up doing is taken some of the longer 19mm sockets here. But if you'll see, the default 19mm socket only has this sort of fairly short bit at the top here. And what I've done is I've moved the pins so that I've got a bit more space on here. And what this means is that when we actually plug this in, we'll actually have sufficient of the pins sticking out here that we can also plug in logic analyzers and things like that, or we could also plug in DuPont cables actually onto these pins as well, should we want to. So we need to then shove the sockets in here. I will go off and cut the various strips to length and push them into the breadboard. It's quite difficult to plug. I think there's about 54 holes down each side. They're trying to plug an 108 pin breadboard adapter into the breadboards. Does take a little bit of work. So I'll just go and cut these to size, so we're actually using all 54 holes, and then I'll come back and then we'll look at soldering all of these pins in and looking at what we need to do to secure these here as well. I've managed to get those 19mm adjusted plugs put into there. It takes a little bit of doing, and now I'm just going to plug in the board here. The board in fact has 54 columns, goes from A to Z, and then there's another A and B down the bottom here. There we go. So that is 108 pins between the two of them, and the way how I've designed this, I'll show you how I've done that in a few minutes. I've done these so that it can actually then plug chips in at appropriate intervals along here, and then there's also sufficient pins here for the ground and possibly even 5 volts in some cases. So I'll show you that in a minute. And if you just flip it over, you can see that there is the wire wrap zone there. There is sufficient for me to be able to get to the sockets. Now what we're going to need to do is to leave this a little bit proud so that the wires can, in fact, the wires are actually going to need to go around the top of here. So these are not going to be plugged in quite as far down as they are at the moment, because we're going to actually put the wire wrap at the bottom part. So basically the wire wrap will go around the bottom there, and then these will plug in. So there will be a little bit of a gap, but that should work out okay. So what I'm going to do now is just show you the layout that I've used for determining this. So just move that out of the way. This is a printout of the diagram, and what I did is I colour highlighted the various colours. So I think ground was green, VCC was red, then control lines I think I did in blue, address lines were in yellow, and the data was in red. And so what I was trying to do is to work out approximately how easily it would be to wire things up. Now the one thing to note here is that when it comes to the address lines, the original 386 PC, the COMPAQ DeskPro, only used address lines up to A23 and then A31. So the A31 is used to divide the address range between above 2 GB and below 2 GB. And this was used for, in particular, there was a 32-bit memory card register for controlling things like shadowing the ROM and write protecting the ROM shadow. Now, that didn't have enough pins with the 2 times 54 pins, there aren't enough pins to do everything. In fact, down the bottom, I did work this out. So we had 132 pins. We've got 8 not connected. There are 7 of these additional address pins up here that we don't have to do. 41 power pins. That gives us 76 plus power. So in fact, we've got 76 pins if we ignore those extra address lines. And then we've got about another 32 that we can use for allocating out to power pins, and also we occasionally need to leave blanks so that we can plug the chips directly in here. So I've used that diagram to try and work out some sort of way of ordering this, and then this spreadsheet is showing the left-hand side and the right-hand side, and this is all with the pin side of the board. Again, if you remember on the diagram I just shown you, the data bus is on the right-hand side, looking from underneath. And you can see here I've worked out from the various schematics and things where we're putting the buffer chip, that in fact that if we arrange the pins with these gaps and things between them, then in fact we allow for the direction pin, for example, and the ground pin on the side of the chip there. And then there's also down the bottom we've got various control signals. And over here we've got the buffer and the latches for the address lines as well. There's still going to need to be some additional logic in addition to this. So it just means that the bulk of the data and address lines can go straight into the appropriate buffers or latches, so we don't have to have extra DuPont cables flying around the place. And then down the bottom here we've got the various byte enables, interrupts. A couple of these signals are needed to be pulled up or pulled down via 20k resistors. These are to do with the Mathco processor. And there's a couple of other signals which, although we're not going to be using in the 386 breadboard PC itself, then in testing it they might be useful. So there's a few more of these signals that I've actually put out onto the pins than I was originally planning to do. And this really is giving me a wiring chart to work out which of the pins in the breadboard adapter need to go to which of the pins for the CPU socket. So before I can do all that, what I'm going to need to do first of all is just to solder these pins in. So once they're all soldered in, they're not needed from the point of view of electrical connectivity. I just need them so that they don't come out. And then once we've soldered those in, I can then solder these sockets. So I need to solder enough of the pins of these sockets just to stop them from coming out. Then I can take these pins that I put in here to hold the socket together. And then once we've done that, we can then lift the whole thing out of the breadboard there, turn it over, and then we can do some wire wrapping. So I'll just show you what wire wrapping is. If you've not come across wire wrapping, something I've not used a lot particularly, but in some of the videos I've covered wire wrapping. So I'll just show you some of those if you don't remember that. And this is the dimensions for that. So this was from some of the earlier videos. This was the original IBM PC prototype wire wrap board. This was the top side and this is the underneath side. So you can see this is all the wire wrapping. And in fact, this is another one from a very early series. The digital PDP-8 backplane was actually a wire wrapped backplane. And if you zoom into this, you can actually see that in some cases the pins may have had multiple wires wrapped onto them. And in fact, on our particular case, we're probably only going to need to do one pin per wire, but because the pins are a little bit longer, then they will allow multiple wires to be connected to each pin. So in order to do wire wrap, what we need is a wire wrap tool. So this is one very similar to the one that I got from Amazon. They're about £20. You can see some of these you can get 4 for £50, or you can get them for cheaper, but the one that I got arrived the next day. And they all tend to be OK Industries, so I'm not sure if any of them are actually different. Virtually all of the vendors are selling the same thing. Now, the key thing when you get a wire wrap tool, you need to ensure that it's for the right size of wire. So this is for a AWG 30 gauge wire, and that happens to be the wire diameter that I'm using. And I'll show you how these tools actually work, because if you haven't seen one before, they are a sort of quite odd. But in actual fact, they're very simple and they do produce quite reliable joints. The only proviso being is that generally you need to use a square pin to wire wrap, and in particular the sockets for the CPU have got circular cross-section pins, which may cause a bit of a problem, but the worst comes to worst is I can dab a bit of solder on some of the pins if it becomes a problem. So this is my wire wrap tool. So basically what you have in this is there's a little wire stripper in here, so you can put the wire through it, and then one end you feed the wire, the stripped wire, into, there's a very, very small bit, I'll show you under the microscope in a minute, but there's a very small hole in the end, it feeds up through here, and then the wire goes up in that channel, and then when you put it over the pin and you turn it, and then it'll actually wrap it, and then the other end is in fact can be used to unwrap. So if you've got a post where you've made a mistake, then if you put the other end in, it will actually unwrap it. So I'll just show you quickly on some simple pins that I've done here. So this is the socket strip that I'm using for the PGA 132 socket. Now, in fact, I've got those thin pins in here, so I can just plug that on there. Now, to do this, you need yourself some wire wrapping wire. So this is a spool I got. It's got 8 colours, so it's quite handy for doing sort of 8 sort of ribbon type things. So that's the wire I've got there. I've cut a few strips here. So here's one that we're going to try using it. See, one end I've already stripped off. We actually just zoom down it, but it might be a bit easier. Zoom down a bit. There we go. You can see that this has got square pins. This is the circular pins. And what you use the wire wrap tool for, you need to strip the insulation off and just stick it in here, pull up, and it comes off. Now, in order to wire wrap a socket, I'll show you this under the microscope in a minute, but basically you have to very, very carefully, we put that in, feed it over the top, hold it, turn it round a few times, and then once it's stuff, should have wrapped that round, and now you can see that has been wrapped. Now, I'm not an expert wire wrapper, and back in the day there were teams that specialised in doing wire wraps, but hopefully for this it will be sufficient for getting me up and going on this. If I just get the microscope out and I can show you a little bit more of what this actually looks like. So I've got my microscope set up here, so if you just look at it now, so what you'll hopefully be able to see here, I'll just move it, is that we've got our yellow wire and it's actually got a number of turns there. Just try and see how many. 1, 2, 3, 4, 5, maybe 5 or 6 turns. So and it's covering, it's going probably about 2 or 3 millimeters. Don't need to have pins which are longer than the PCB connector. You can see there 1, 2, 3, 4, about 5 connections. Now I'll just try and do it for do the other end for the other pin. So we're going to try and connect it onto one of these other pins. So again, we just sort of get the bare end, feed it in the end of the wire wrap tool, push it over the pin, it does fit over the pin, and then we just turn it a number of times. Once the tail of the thing disappears, we can see that wrapped the thing around there. It does turn a little bit, so I think I am going to have to probably touch these up with a bit of solder to stop them from turning, but it will actually rise up the pin if I'm not careful. Let's just have a look at that under the microscope. So hopefully you can see this. Now, this is not quite the way how it will be, because there is a little shank really at the end of the pin, and that's going to be on the top side of the printed circuit board, and then the wire wrap is actually going to be going flush with the circuit board. So it may be that this will be a little bit better when it's not having to deal with this little shank at the bottom of the pin there. But it does it can move up and down a little bit, and really we do need square pegs. So I think I probably, once I'm sure that I've actually got the right connections here, I am probably going to need to touch these up with a little bit of solder. I do have another type of prototyping thing, so something called a Roadrunner wiring pen. This is a Roadrunner wiring pen. This is a very old one. I had this from about 1980. And the idea of this is that the spools of wire here has insulation on it that can be burnt off. And so what we actually do is we put the pen on a pin, wrap it around a few times, but unlike the wire wrap, we actually then just cut them off. Unlike the wire wrap, what you'd actually do is to solder that, and the insulation is such that it would actually, it's designed to burn off and to give a good joint. So if the wire wrapping wire doesn't work out, the worst comes to the worst is I'd have to use this type of wiring pen anyway and solder both ends, but hopefully it'll only be one end I need to solder for the circular pins. If anyone knows where you can get these types of sockets for wire wrap purposes, then that would obviously solve the problem. But for now, I'm going to go ahead with this, and what that will allow me to do is to wire this all up, and I'll just touch each of the points here with solder, just make it a little bit more difficult to unwrap it. And if we just then take the wire wrap and take the opposite end of the wire wrap tool, if we take this off, we should be able to twist it a few times round, and then we now have been able to undo the wire wrap. So you probably have to cut this off and strip the insulation off it, but the wire wrapping will allow you to undo things, obviously assuming you haven't had to solder the things in. So I'm going to do a bit of experimenting here. I'm not going to be videoing the wire wrapping 120 odd pins. I don't think it would make it for a very exciting video. So what I'm going to do off camera, I'm going to solder all of these pins in. I'm going to solder quite a few of these pins so that the sockets don't actually come out. And then I'm going to unplug this, and I'm going to start wiring in all of these things. And I have a printout of that. So basically what I've got to do is to go through that sheet, making sure I wire up the appropriate pin here, that when I've taken out the breadboards, then I've got these labels that I'll stick on the PCB on the proto board next to the pins. And so basically means that what I'll just need to do is to go to this and to check to see that I've got the appropriate H1, for example, is going to be going to pin 9 on the left hand side. So I need to find H1 and then go to pin 9 on the left hand side here. So I should just be able to wire wrap, but that's probably going to take a couple of hours to do that, I imagine. So what I'll do is I'll record the completion of that, and we'll look at that at the beginning of the next video. Just turn that over. Again, these sockets, I just have to remember that things will be reversed. So the address is going to be on this side and the data is going to be on this side. But the way how that has worked should mean that I'll be able to plug in the various chips here. The way how this will work is hopefully I'll just be able to put the various chips, the appropriate points down the side here, and it will minimize the amount of wiring up. And because I've managed to make these pins a little bit longer than they would otherwise be, I've changed the balance between the top of the pin and the bottom of the pin for these 19mm pins. And it also means I can plug in DuPont cables into here, and I can also plug Logic Analyzer into there. So hopefully this will mean that it'll minimize the amount of wiring we have to do down the sides here, but it will also allow flexibility to wire in extra cables in here when needed to. So in the next video, I'm going to be looking at the completed breadboard adapter. And then what we're going to start to do is to wire up the clock circuit and actually start to see if the chip is working and the breadboard adapter is working. And then we'll set the data bus lines to be the no operation code 90, and we'll see whether or not we can get the address lines to go up in sequence. So if you don't want to miss out on future videos, then please hit subscribe. And if you can hit like as well, it just helps to make the videos available to more people. Please feel free to comment. I do try and respond to comments within a day or so. Thanks for watching.